hope you are doing good. So I'll just run the analysis for you through eViews and explain what those results mean. Actually, I have also discussed those in the document that I have sent you, but I'm just gonna do it again in order to clarify the concepts that I have used, because the model I have used is quite different than the normal ones you usually use for the analysis. So let's start. First of all, I'll go and open the eViews software. So I have two eViews installed basically. Number one is 10th one, so I don't have registered one version. I'll buy it very soon. And another one I have is eViews 9. So I'll open the eViews 9. Pardon me. We have eViews 9 window. It looks just like the one that is before us. And now we'll have to create a new work file. So we'll go into this. Now we see multiple columns here visible to us. One is work file structure, other one is desk specification, then there is a work file name. So work file structure, we select unstructured. So in number of observations, for example, we have to put the maximum number of observations that we have in our data. So we are not certain about the number of observations. We can see in the Excel that number of rows in columns, so we can just put a maximum number that could be in our idea. For example, 10,000, it won't be more than 10,000. I'm giving it a name and opening it. So here we have a window that is work file I have created with your name. Now I go and import the data. Now there are two ways to import the data. Number one, you can just go here and import from a file. That could also work, but I personally like another way, that is here, aggregate data. I'll just drag and drop it here. Next, everything is okay, and then I'll just go and finish. I'll have to select it. Okay, I'll close the other windows and just maximize this one. So now in order to run the ARDL model, we have to select the variables very carefully. First we have to select dependent variable. So this is the dependent variable quantity adult. So we are checking the impact on sales. So let's select this, then cost per ticket, then post it cost per ticket, and then a revenue. Now I'll click the right to mouse or touchpad you have. We'll open it as an equation. So let's open the equation. Here we go. We have that option here. Now see, in order to select the ARDL model, we have to select a method. Currently, the method we have on window is least square. But now we'll select it and go down and select autoregressive distributed leg model. I repeat, ARDL, autoregressive distributed model. So let's go in it. So we can select the legs. Legs is the difference between the periods that shows us adjustment in the time. So let's go and okay. Now here are the results that we have. So let's first explain them. For example, see, we have lag of quantity. We usually in the regression, simple regression, linear, multiple linear regression, or simple regression, we do not have a dependent variable in the table, but here we do, because we have checked the first difference of it as well. So this is strong and significant. So the adjustment is increasing. Then we have cost per ticket at 0th time at par. So that is negative and significant here, -287. So we have a definite definition for it, which is correct in terms of concept, in terms of evidence, or all, that whensoever the cost is increased, the revenue also increases, but price is supposed to be increased. And now that increase in price will reduce the demand. So increase in cost will have reducing impact on quantity of sales. But we see that in the first period or second period or third, this gets recovered here, 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 and all those are significant. And the second one is significant at 10%, but that's totally about precision, nothing more than that. Then posted adult cost per ticket is also significant. Revenue is significant, and then at the first period the revenue decreases. Now there could be multiple reasons because of that. It could be about seasonality, it could be due to price effect, it could be due to cost effect, so many different things, but that will adjust itself again. But this is just ARDL, but we have to see diagnostics whether data is fine, data is rightly distributed, or if so is the case, we must have a definite answer to that. So first of all, in order to explain that thing, we'll go for residual diagnostics and we'll check for normality test. Now here we have a normality test. These are the figures. Mean is fine, median, we don't have to see actually these figures. What we have to focus on is skewness, kurtosis, Jacobera. So skewness is fine. The normal threshold for skewness is that the value should be between -2 and 2. Now that is the normal figure. It's 1.7, so it's fine. As per the skewness measure, the data is normally distributed. But kurtosis is not fine because the values are not under the threshold, and Jacobera is also significant, which means that data is not normal. Now, what could be the reason for these two figures, kurtosis and Jacobera, for being not normal? Because we have extreme outliers here. See, at this point, again, these are outliers. This is the outlier, this is the outlier, but we can't ignore these. We can actually adjust them for the analysis, but we don't have to ignore them because it will not be realistic then. So in order to keep the analysis realistic, we'll have to go with the data we have. So we have a justification for abnormal distribution of the data, so we can keep it that way. We don't have to mess with it, we just need to explain it, we need to understand the situation. Now serial correlation, we have to check that this again. Now this is 0.76. It is insignificant. It means that there is some serial correlation among the data, but again, because the cost and revenue and price, they go hand in hand, so there must be some serial correlation between them, but we have to avoid that. Problem is we just simply can't, because the data has a behavior, the data has a pattern. This thing is that we don't need to compromise on. This is heteroskedasticity. In regression assumptions, for any model, you must have assumptions. For regression, one of the assumptions is that there should be no heteroskedasticity. There should be homoskedasticity, which means a constant variance. So let's check this. Now here we have F statistic 12.32 and probability against that is 0.000, which is significant. Now, in order to do or understand this, we need to know the null hypothesis. The null hypothesis is that there is heteroskedasticity, but we reject the null hypothesis and say that there is no heteroskedasticity, means there is homoskedasticity, a constant variance in the data. That is fine. That is within the bounds, as per the results, and fine with our approach. Now we have to check for stability diagnostics, that is Ramsey test. Again, here the bounds are very small, but we can say that they are significant. The model is perfectly specified based on the p f value and t value. P values against that, which are 15%, they are significant at 20%, which is not considerable actually. Now we have to see the model stability, but first we need to go to estimation output and representations. We need this equation, so we'll just simply go copy it, and we need to close this. We'll keep these fine and open another equation, but before, so we have to paste the current equation and go with the linear regression or the least square model. So let's, okay, now before going towards the next equation, we have to save the first one, so we'll just save it with ARDL name. Let's say okay. Now that equation is saved and we have another output before us. This is the least square model, linear regression or multiple linear regression. Here all we need is go to the recursive estimates and see the stability of data. For that, we have two models. Number one is QSUM test. Let's go and check it. We need to see that the blue line that is showing the QSUM measure is within the bounds of 5% significant. So between these two lines, so we see that this is within the bounds, and we are fine with here. We are good to go with this. And another measure is QSUM-Q, that is again here. Now we see that there is a problem here about the data. But again, it's totally about the data. The data is realistic. We have to keep the realistic figures. So we are fine to go here as well. But we need to see actually if that data is not too worse. Thank you. That's all about it. We will save this equation again. LS is B. We are running linear least square for stability. And okay. Now we have to save this model. File, save as. I'll go to the folder that I have saved with your name here, and I'll save it with model save. Let's go with 16-digit precision, and this precision is about the decimal figures after the point actually.